Okay, creating histograms. First of all, this is called a frequency table. So they gave us some data and they're giving us a frequency table. So basically with this problem, they're telling us the width of our bars. We just learned in a video that the bar width can change. However, on a problem like this, you are going to be given the width of the bars. So all I'm going to do is go down through here and make tally marks into which one each one goes into. So 12 goes into this range, 17, 14, 9, 5, 8, 11, 13. Oops, that one should not have happened. So we're going to scribble out that one so we're still at 4. 15, 16. So this one ended up with 0, and then we have 3, 4, and 3. So that's my frequency table. Don't just leave it at the tallies. Make sure you go ahead and draw that out. Now, creating our histogram. That's a beautiful straight line right there. I'm an artist. Now, at the bottom you draw your bars, 0 to 4, 5 to 9, 10 to 14, and then 15 to 19. Okay? Up the side is going to be the frequency, whatever it happens to be. In this case, I'm just giving you some random numbers. So 0 to 4 is 0, which means I don't draw a bar at all right there. 5 to 9 is 3, which means when I draw this up, the entire width of the bar is that. Now, one thing to be very, very careful about. If I'm looking at a histogram, I can't tell you the exact data point within that range. All I know is there's 3 values between 5 and 9. Okay, so that's where a histogram does fall apart. You can't tell an exact mean or an exact standard deviation or any of those things because we don't know what the actual numbers are. We just know that there's 3 numbers between 5 and 9. As far as we know, all 3 of them could be 5s, or all 3 of them could be 9s, or it could be a mix. We don't know. Now, also with histograms, you just learned, you have to connect up the bars. Okay, so the 2 bars are touching right there, and that one goes all the way up to 4, and then over here my last bar is a 3. All right, so that's how you draw a histogram. Now, we're going to be talking about a lot of stuff here in just a second about finding the mean of a histogram and finding the standard deviation. It's impossible to find an exact mean, but here's what I do. I always find the middle part of my data. Okay, so the middle of my data, I'm dealing with 3 bars, so the middle of my data is going to be in the second bar. So that's the middle of my data. Now, my mean is going to shift to where the higher bars are. It doesn't have to shift a lot, but it's going to shift to where the higher bars are. In this case, we're perfectly symmetric, which means my mean is going to fall somewhere around the middle of my data. Okay, so my mean is somewhere around 10 to 14. Don't exactly know where. Standard deviation. Standard deviation measures spread. We want most of our bars stacked around the middle of our data. So we want most of the bars stacked around the mean. So in this case, our bars are stacked around the mean, so the standard deviation is going to be relatively small for this type of a problem. All right, so that's creating histograms and kind of how to eyeball the mean and the standard deviation. Now, you actually have this worksheet in your packet, so I want you to look at it, and I'm going to walk you through just a couple of different type of problems. It's telling you the mean is 2.57. So the mean is right here. For this one, the mean is right here for this one. So I'm going to draw a line all the way up and down. Now, the question is, which one has the highest bars stacked right around it? We don't want our data spread out. We want our data stacked tight. If the data is stacked tightly, then that means it has a relatively small standard deviation. If the data is spread out, much like this one is, then it's not a small standard deviation. This is not a normal curve, but the closer we can get to a normal curve, the smaller the standard deviation. So, looking at these two, if I had to pick one that had a smaller standard deviation, which one has more data packed around it? It's going to be A. So when I go over here to my choices, it says B has a larger standard deviation than A. That's my correct answer because A has a smaller standard deviation. Okay, let's look at the next set of data. It's telling me my mean is 2.33. So right there, mean is 3.33, right there. I want you to take a second and kind of think which one's going to have a smaller standard deviation. All right, remember standard deviation measures the spread. You want most of the bars to be right around the mean, the highest bars around the mean. Well, this one doesn't have any bars around the mean at all. Okay, so that means my data is spread out away from my mean. This one, the data is in the highest, my mean is in the highest bar. So that means this one has a smaller standard deviation. So that means B has a larger standard deviation. Now, I'm going to do one or two more with you. You have plenty of practice problems, so I'll probably finish up a couple more pages right here. Let's look at these two. All right, very important. What do you notice about them? Well, first of all, you notice they're the same exact shape, okay? The mean's on the other page, but let's look at it and try to figure out the mean without doing it. So pick the middle of it. There's two bars, so that means the mean, if it were perfectly symmetrical, would be right in the middle. Now we shift our mean to the highest bar. So that means my mean is going to shift left just a little bit. So my mean's probably somewhere around in there. Let's look at this one. The middle of the bars, the middle of the two bars would be there. If it were perfectly symmetrical, my mean would stay there. However, highest bars to the left, so it shifts my mean a little bit to the left, so my mean's probably there. Now, this graph, graph B, has a higher mean than A. That's obvious. The mean is 4.3, the mean is like 0.3. Okay, so it has a higher mean. However, standard deviation measures spread. These two things are exactly the same shape, which means their standard deviation is the same. If two graphs are exactly the same shape, that means the standard deviation is the same. The mean is different, the standard deviation is the same. All right, let's look at number 4. This might be one of the last ones I do with you. Again, just ignore the mean for just a second. Act as if it's not even there. 1, 2, 3, 4, 5, 6 bars. Okay, so that means my mean is going to fall right in the middle of these bars. I know it's saying 2.5, but it's easy to say it's right there in the middle. They're giving you it because they actually know the data points. Over here, 1, 2, 3, 4 bars. So that means my mean is going to fall right there. So the mean on both of these are about the same. However, which one has more data stacked around the center? Well, this one has more data stacked around the center. So this one has a smaller standard deviation. This one has a larger standard deviation. The data is more spread out. So when we go over here to my answer, A has a larger standard deviation than B. Hopefully that gives you a good idea on how to look at histograms, and that way you can go ahead and finish out this worksheet.